Welcome to Study Loop.
Hi. In this video, we're given that a golf ball is struck on the moon with some velocity and some angle, and we're going to answer some basically physics questions about it. So let's just jump right in. For the first question, it asks for the vertical and horizontal components of the ball's initial velocity. So the ball we're given is hit at an angle of 40 degrees with a velocity of 48 meters per second. So what we need is to find the x and y components of this vector here. And then it's actually quite simple. So we have vx, vy. We just use trig functions. So we say that vx, or actually let me say it this way. So we know that sine of 40 degrees is equal to vy divided by 48. So vy is equal to 48 times sine of 40. And similarly, cosine of 40 degrees is equal to vx over 48. So vx is equal to 48 times cosine of 40 degrees. So this is the answer to part A. For part B, we want to find the hang time of the ball. So the way I'm going to do that is to write the x and y position functions. So the x position function, there's no initial, we're going to assume the ball starts at 0, 0 at the origin. So its x position is just going to be its x velocity, so 48 cosine of 40 times t. And then the y, we have 48 sine of 40 degrees times t. And then we have acceleration, so minus 1.6 t squared. Now to find the hang time of the ball, we can just find the time when y of t is maximized and then multiply that by 2. So because y of t is a parabola, we can find its vertex using negative b over 2a, so the vertex of a parabola. So it's negative 48 sine of 40 degrees divided by 2 times negative 1.6, which is approximately this is approximately 9.64. So the hang time is just going to be double that. So it's going to be about 19.28. And then for the second part of B, we want to find, second part of B asks how far away the ball will land. So the hang time, so we just have to evaluate the x equation at 19.28. Because 19.28 is when the ball will land. So if we plug that in into the x function, we just get about 594.97. And then finally, how high will the ball land? So remember, that's at the vertex, right? That's the time when the height is maximized. So that's just y of 9.64, which is about 148.74. And that's it for this problem.